Hello everyone, welcome back to this online class. Today I want us to verify these two identities. We are given that z is equals to x plus iota y, and you are asked to show that in part A that cosine of z is equals to cosine of x times hyperbolic cosine of y minus iota times sine of x times hyperbolic sine of y. And in part B, we are asked to show that sine of z is equals to sine of x times hyperbolic cosine of y plus iota cosine of x times hyperbolic sine of y. So let's start with the first identity. Solution, part A. You see, we are asked, let me write that in a proper way. That is part A. So in part A, we are asked to find cosine of z. So when you replace z by x plus iy, remember the substitution. We are told wherever there is z, you need to put x plus iy. So this is the same as cosine of x plus iota y. Remember cos A plus B. Remember the expansion for cos A plus B is the same as cosine A cosine B minus sine A sine B. We also know that sine of A plus B is the same as sine A, that is sine A cosine B plus cos A sine B. So we are going to use these identities to be able to expand cos A plus B and sine A plus B. So that here we now have cos x cos iy minus sine x sine iota y. I also want us to take note of these other identities. So you can also take note that cosine of theta is the same as exponential I theta plus exponential negative I theta, everything divided by 2. We also know that sine of theta is equals to exponential I theta minus exponential negative I theta divided by I2. So we are going to use those two identities so that here we'll now talk of is equals to cos x. Instead of cos iy, we put our theta. Where there is theta, you put iy. So this is the same as exponential I times theta, which is iy, plus exponential negative I times iy, everything you divide by 2. Then minus sine x, Then we now need to expand sine iy. So where there is theta, we are going to replace that by iy. So we'll have this as exponential iota times iota y minus exponential negative iota times iota y, everything over iota 2. I there is iota, is a Greek symbol, read as iota. So I want you to take note that I squared is equals to -1. So wherever you have I squared, we are going to substitute -1. And I squared is the same as I times I. So this can now be written as cosine of x, that is x. Let me write in a proper manner. Cosine of x times exponential -y plus exponential negative. Of course, negative times negative, it becomes positive. So this is just positive y, which is y over 2 minus sine x. Let me factor out 1 over I outside of, or simply 1 over I. So instead of factoring out, this can still be written as exponential -y minus exponential, that's now positive y over, remember this was I2. So this I2, of which this can be written as, this can be rewritten as cosine of x times exponential y plus exponential -y over 2. Then I factor out -1 over I is the same as now positive 1 over I outside, then sine x. Then we have exponential y minus exponential -y. Then this is over 2. I factor out -1 over I, so we get positive. I also want us to take note that when we write hyperbolic cosine of theta is the same as exponential theta plus exponential negative theta over 2. And when you talk of hyperbolic sine, let me write it. When you talk of sine h of theta, hyperbolic sine of theta, it is the same as exponential theta minus exponential negative theta, everything over 2. So I'm going to apply those identities so that in our final answer, this can now be written as cosine of x, and then that bracket is the same as hyperbolic cosine of y. Then what is plus 1 over I? Also take note that 1 over I is the same as I over I squared, which is I over -1, and that's negative I. So wherever we have 1 over I, we are going to replace that by negative I. Then here we have sine x. Then the other one is hyperbolic sine of y. So we have shown the identity in part A. Let us also prove the identity in part B, identity for sine z. So we are going to write part B. Part B, you write sine of z is the same as sine of x plus iota y. Now use the expansion for sine A plus B. Look at it. Let me take you up. Sine A plus B, we have it here. So it will be sine A cos B plus cos A sine B. Instead of A, we are going to use X, and in place of B, we are going to use I, Y, iota Y. Now, let's expand it. This will now give us sine x cos iota y plus cos x sine iota y. But from here, we have shown that cos iota y is the same as, look at the way it was, where there is cos iota y, that is the same as hyperbolic cosine of y. That's what we got. And where there is sine iota y, what did we get? We got I sine hyperbolic of y. So this can now be written as, remember from part A, instead of having to do the same thing again, from part A it is clear that where there is hyperbolic cosine of iota y, they should give you hyperbolic cosine. Now this cos iota y, let me rewrite it. Cos iota y should be able to give you hyperbolic cosine of y. What about sine of iota y? What are we supposed to get? Look at part A. It was sine x times sine iota y. And in our answer, when you do the comparison, sine x, then it means the other part will be I times sine hyperbolic of y. So that will give us I, then hyperbolic sine of y. So that when I come to part B, because already I've shown you how to apply those identities, what you are going to get here is sine x instead of cosine of iota y, that's the same as cos y, or hyperbolic cosine of y. Then remember this is negative, so this will be negative. You see the comparison? Not negative, that is positive. So just change that, not negative, it should be positive. So plus I, this is cosine of x, sine iota y, I already have cut out for the iota, so this is sine hyperbolic of y. So we have shown. Now what is important is knowing these identities. You see this, how to express trigonometric functions in terms of hyperbolic functions. Sine iota y is the same as I times hyperbolic sine of y, and also cos iota y is the same as hyperbolic cosine of y. These relations are very important. So thank you all for watching this video. Please subscribe to my YouTube channel. That is Professor Francis Okech. When you go to the YouTube search, type Francis Okech or Prof. Francis Okech, and you will find me right there. Also comment, like, and share this video. When you meet next time, we look at other problems in complex analysis. Thank you all. Bye-bye.